We're not going to do warm up today. We're just going to jump right in to conditional probability. So the idea behind conditional probability is that you already know some of the information. So we're going to use the product rule for independent events. You have seen this before. The probability of A and B happening when B is conditional on A occurring is the probability of A times the probability of B happening such that A has already occurred. So there are three different ways of writing it down here, knowing that you can use the probability of A and B over the probability of A to arrive at the probability of B happening such that A has occurred. Right? These two equations are just rewritten. Or we can get the probability of A such that, or given that, A has happened by the number of B and A divided by the number of A. So we need to dive into an example here. So below we've got the results of a survey for 100 grade 12 mathematics students at Voden. This would be back in the day when we had 100 grade 12 students. Anyway, determine the probability of selecting a data management student given that the student is enrolled in advanced functions. All right, so we have to sit here and actually I'm going to change the numbers. I'm going to change the advanced functions and the calculus numbers around. Right. So we got a lot going on here. So we've got advanced functions, we've got calculus, and we have data management. So you have done these Venn diagrams before. So we're going to make up a 3-circle Venn diagram. And remember, we're going to start in the middle. So we have 5 that are taking all 3 courses. It says that right down here at the bottom. We have 6 that are in advanced functions and data. So we have to include that 5. That means we have only 1 here that only took advanced functions and data. We've got 30 that took advanced functions and calculus, and subtracting off the 5 that took everything. And then we have 50 that took data management and calculus. Got to subtract off the 5 that took all 3. So now we can work our way out. So we've got 33 that took advanced functions. Well, we've already accounted for 31 of them, so that means only 2 students just took advanced functions. We had 80 in calculus, wouldn't that be the day? And we have 75 accounted for, so there's only 5 that took calculus. And we have 68 in data management. We have already accounted for, 51 of them. So we have 17 students that just took data. So determine the probability of selecting a data management student given that the student enrolled in advanced functions. So the number that we have to start with is the students enrolled in advanced functions. That is our sample set. And then the number that took data and functions, there's 6 of those. So let's read the question. It says, what is the probability of selecting a data management student given that the student enrolled in advanced functions? All right, so we want a data management student given that they're enrolled in advanced functions. And we know that there are 6 of those. So the probability of choosing one of those 6 is the probability of choosing a data management student such that they were enrolled in advanced functions. So we can do that by saying it's the number of students that are in data and advanced functions over the number of students in advanced functions, which, as we knew, was 6 over 33. So 2 cards are going to be drawn, no replacement. That is important, right? Because we're changing. This is now a conditional probability because we are not replacing the card. So determine the probability of drawing 2 aces given that the first card was an ace. So first we need to know what are the number of aces and what are the total number of cards in a deck. So we know that there's 4 aces and 52 cards in the deck. So the probability of drawing a first ace is 4 in 52. Now the second ace, given that the first card was an ace, is now down to 3 in 51. So the probability of that happening is 12 in 2,652, which is a 0.0045, which is 0.45% probability. So let's just think about this next question for just a second. It says, what is the probability of drawing 2 aces given that the first card is not a king? Well, first of all, if the first card is not a king, that means that we're going to take 4 out of our sample set, right? Because if the first is not a king, that means that I'm only pulling now from 48 possibilities. So that first card is now a 4 in 48, given that we know the first is not going to be a king. Now we know that that was only the first condition. And so now we've got 1 card drawn. We have 3 aces left. There's no condition on the second one not being a king. And so now we have 3 of 51 potential aces left in the deck. So you can see we have improved our chances from a 0.45% chance to a 0.49. Woo! The probability that a student studies both physics and chemistry at Ridgeway Technical School is 0.15. The probability that a student studies physics is 0.6. What is the conditional probability that a student studies chemistry given that she is in the physics class? So we have been given all probabilities here. So we want to know the probability of chemistry given that they are in physics. So we use probabilities. So we know what probability of them being in chemistry given that they're in physics is the probability of them being in chemistry and physics over the probability of them being in physics, which is 0.15 over 0.6, or 1/4, or 25% chance. So this is a fun one. 3 cards are chosen from a standard deck without replacement. Okay, we know it's conditional. What is the probability of getting 3 of a kind? So the probability of getting 3 of a kind, remember there are 4 suits. So we're looking for the probability of getting all spades, or all hearts, or all clubs, or all diamonds. So we need to be looking at all of these probabilities. So remember it's or. So we're adding, and adding. So the probability of having it all spades is 13 over 52 times 12 over 51 times 11 over 50, but that's the same for all of them. Right, so I'm not going to write that out 4 times. I have 13 spades of 52. When I take 1 out, if it's a spade, then I have 12 spades left of 51. If that's also a spade, then I have 11 spades left of 50. Same thing with clubs, hearts, and diamonds, so I'm just going to take this and multiply it by 4. I am going to say, though, that before we do this, you want to be looking for ways that you can reduce these fractions before you do this, because this is going to be awfully big numbers. Now, I did say that you can also just turn it into a decimal, but it's math class, so I like to use math. So when I do all my reductions, I end up with 2 times 11 over 17 times 25, or 22 over 425, or 5.2% chance of getting 3 of a kind. A box contains 5 slips of blue paper numbered 1 to 5, 6 slips of red paper numbered 1 to 6. What's the probability of selecting a random slip that is blue and has an odd number? Okay, so blue paper numbered 1 to 5. So there's our red numbers and our blue numbers. Now, which of them are odd? So it is the odd numbers that is our sample space, because we're looking to see the probability of selecting a random slip that is blue and odd. So the odd numbers are our sample space, and there are 6 odd numbers. And so blue, given that it is odd, I have 3 of those, right? So the number of blue and odd over the number of odd. So I have 3 blue odd numbers and 6 odd numbers in total. So I have a 3 and 6 chance, or a 50% chance, of drawing a random slip that is blue and has an odd number. Oh, the school bus problem. Josiah has a 20% experimental probability of hitting the snooze button any morning when his alarm goes off. So experimental, not theoretical. When he hits the snooze button, there is a 25% conditional probability that he will miss the bus. He has never missed the bus when he has not hit the snooze button. So if Josiah's alarm woke him 120 times over the course of the semester, how many times did he miss the bus? Ooh, how fun is this? So we're going to tree diagram this just to help you with this. So remember, he has a 20% probability of hitting the snooze button. So that has to go on the arm that goes to snooze. It means he has an 80% chance of not hitting the snooze button. So now remember, there's a conditional 25% probability that he misses the bus, meaning that if he hits the snooze button, there's a 25% chance that he's going to miss the bus. So now the probability of him hitting the snooze button and missing the bus is 0.2 times 0.25. So just for fun, we're saying that the number of times he hit the snooze button and didn't miss the bus, or probability, is 0.15. So we're looking for, if Josiah's alarm woke him 120 times over the course of the semester, how many times did he miss the bus? So the number of times he missed the bus is going to be that 5% experimental probability times 120. Or he missed the bus 6 times over the course of the semester. 6 times too many. I would like you to try this one by yourself. So I would like you to pause the video to give this one a try. And I am going to do the answer here. I'm not going to explain the answer. I'm just going to write it down. So please try this one on your own.